Hello, this is Mr. Miller. I hope you're doing super. This is video number 25. We're going to talk about the triangle sum theorem. We're going to talk about what the angles of the triangle add up to. Most people already know that the angles of the triangle add up to 180 degrees, but I want to give a little demonstration here. I have a program called Geometry Sketchpad, and we can see that this is really true. I have a triangle here with vertices A, B, and C. And the program measures the angles for me. Angle ABC, which is this one down here I'm pointing to, is 32.9 degrees. BAC is 79.5 degrees. That's this one up here. And ACB is 67.60. So the computer measures the angles very accurately. And then I told it to add it up. And big surprise, the three angles add up to 180. What's kind of cool about this is you can move it around. So I can stretch this, make all kinds of triangles. And you see that the angles change as I move the vertices. The angles change, but the sum of the angles remains 180. So no matter what I do, I can make an obtuse triangle, an acute triangle, a right triangle, you name it, really, really stretched out triangle like this, really big or thin or big. And always, the sum of the angles is 180 degrees. In geometry, sometimes it's called an invariant. Something that's always true is an invariant. Okay, so the angles of a triangle always add up to 180. So like I said, you can play with this all day, and you're going to get nothing but 180. All right, I want to talk about how to solve three different types of problems. First, we have problems where just numbers mostly are given. No expressions, just x itself. So we want to find the missing value. Okay, so here, two angles of the triangle are given. Whenever I'm giving two angle measurements, we can always get the third. So in order to find x up here, all we got to do is do 180, which is the total of the angles, and subtract off the angles we have. 32 degrees, so it's 180 degrees, minus 32 degrees, minus 71 degrees, and we get what our missing angle is. So all we need is a calculator, and we can kind of do this kind of problem very quickly. And I get 77 degrees, so 77. So this angle is 77 degrees. Okay, on this triangle here, same thing. I'm given two angle measurements. I'm going to do 180 minus those angles. So minus 24, minus 33. Let's see what we get. We get 123 degrees, which makes sense. That's a big obtuse angle there. So 123 sounds right. On this one, in case you don't know, this little box here in the corner means that this is a right angle. So it counts for 90 degrees. So we can't forget about that when we're subtracting the angles. So it's 180 minus 90 minus 64. Whatever's left is our angle measurement. So 180 minus 90 minus 64. Got my calculator here. Is 26. So this must be 26 degrees here. All right, I threw in a little bit more complicated problem here. Sometimes we have to find several angle measurements before we get to the one we want, x. And I just have to start looking where I can fill in angles. This 28 degrees down here really doesn't lead anywhere because I don't know two angles of that triangle. And I don't know what this total is, so that's not helpful right now. This 84 degrees I can get somewhere. This 80 must be 84 over here because these are vertical angles. These two add up to 180, so this must be 96, and this must be 96. Okay, so I got three angles, and now that I start looking, I see I can get some more. This triangle up here, the angles have to add to 180, so if I do 180 minus 96 and minus 23, I get 61, so this must be 61. And now that I know that angle, that gives the one next to it, because they must add up to 180. So we get 119 for that one. This is 119 plus 61 is 180. Let me take a look. Do we have enough to get the angle down here yet? Let me see here. Oh, this is 119. Actually, we do. This angle and this angle are two angles of this big triangle. So x must be 180 minus 119 minus 28. So let me see what that is. And we get 33. So this must be 33. So this equals 33. All right, super. So sometimes you're just going to have to start finding angles you can find. It started around here, finding those three, which led me to be able to solve this triangle, which ultimately led me to solve this kind of triangle down here. Okay, and we finally got 33. All right, so that's the kind of skill level you're going to be at. This right here. This is your level of problem, and we'll practice those. Okay, here's another type of problem. These have expressions. So this is going to be no problem for us because we know the fact the sum of the angles equals 180. So we just have to add up the angles, 2x plus 6 plus 78 plus x, and set it equal to 180. After that, game over. 3x plus 84 equals 180. If I subtract 84, I think I get 3x equals 96. Or x equals 32. Bam, that easy. So here's another one. It's a triangle, adds to 180. That should get us going quickly. X plus 9 plus 4x plus 9 equals 180. We got three x terms. They combine to 6x. We got two 9s. That's 18. And here we go. I just need to do 162 divided by 6. And we get, works out to be 27. Okay, so these algebra problems will be very quick for you because we know the fact they add up to 180. And so nothing but a little bit of algebra. Here's the last type of problem. And this might be a little bit new to you. And we'll see this with polygons also. It says the angle measures of a triangle have ratio 1 to 3 to 6. What that means is it's some multiple of those numbers. It could be 2, 6, and 12. I multiply them all by 2. That doesn't add up to 180 though. Maybe I can multiply them by 3. That would be 3, 9, 18. Or maybe I multiply them by 10. That'd be 10, 30, 60. But it's some multiple of those numbers. The way we set up this problem is to represent them as 1x, 3x, and 6x. Since I don't know what to multiply all three numbers by, I multiply them by x, and those are my angles. So usually it draws just some generic triangle. It really doesn't matter if it has the right shape or not. We don't know the shape. But this kind of helps it look like the other problems we've been doing. So I know one angle is 1x, another one's 3x, and 6x. And now I add them and set them equal to 180. And I get 10x equals 180, or x equals 18. And now that I know x, I can go back and find all of the angles. 1x is 18. 3x is 54. And 6x would be 60, and 48, I think, is 108. And I should put degrees. These are the measures of all the angles. There it goes. It says find the angle measures of the triangle. There they are. All right, so it turned out that 18 was the number I should multiply 1, 3, 6 by. When we multiply all those by 18, we get 18, 54, and 108. Okay, now once you know the secret, just got to remember it. These problems are easy. So here on this one, I'm going to represent my three angles as 4x, 5x, and 6x. X is a number that's multiplying all of those. And again, don't know the shape of the triangle. I'm just using it to kind of help me here. Visualize it. So 4 plus 5 plus 6, that's 15x equals 180. So I believe x equals 12. Now, you got to answer the question. It said find the largest angle. The largest one would be 6x. So largest angle it's really hard to write here. So largest angle equals 6 times 12, or 6x, which is 6 times 12, which is 72 degrees. All right, cool. All right, let's take a look. Next slide is journal time. All right, we've made it. So here are 3 problems, one or two of each type. The first 2, just got to find the missing angle, remembering the total is 180. Second one, have to write an equation and solve it. The third one, I want you to draw a sketch, kind of like we did in the figure. It doesn't have to be accurate, and label it. And we want to find a triangle that has angle measures with ratio 2 to 3 to 4. So just follow the examples, and we'll check it in class. See you next time.